Morgan, and our team is undertaking the small geothermal power plant project. I'm motivated for this project because it has practical implications for the advancement of renewable energy utilisation.
Hello, I am Vlad, and during my time at university I have been heavily involved in the field of power engineering and generation with a strong focus on renewable solutions. Out of all the thesis and project topics available, this was the choice that best allowed me to further my interest in the field.
Hello, I'm Callum and I've had a passion for energy, particularly renewable and cleaner sources, and have consequently revolved most of my university and work experience projects around this. This project directly aligned with my interests and will be my first opportunity to work with geothermal technologies.
Hi, I'm Mech. I enjoy thermodynamics and working on design projects, so it just made sense to do this project. Plus it gives me an opportunity to design something that could help people in need.
It is a project to bring cheap power to many people in the poor countries. Places like Indonesia, Philippines, Kenya, plus quite a few others. There are hundreds of millions of people without access to electricity. Most of those people have access to hot water, so your project hopefully will produce some technology to generate electricity for them.
Working with our supervisor, we have together defined the problem as follows. In collaboration with Professor Hauger Gensi, EWB is looking to utilise geothermal resources to provide a renewable electricity source to remote communities in developing countries.
With our problem clearly defined, logically our next step was to specify the boundaries of our project. From the outset of the project, we had already been given an outline of a potential workable solution. However, we found this design brief to be too specific, and Hal agreed to our revised scope, broadened to cover the following topics: a discussion of available technologies and all potential solutions, description and justification of the proposed design methodology, detailed outline of design implementation, and complete design for manufacture, including a full set of engineering drawings, detailed parts list and specifications, assumptions, limitations, operating parameters, and expected output. Obviously, the project is centralised on geothermal power, and thus we will not be considering other energy sources, except in a potential composite system. Nor will we analyse the geothermal wells, as all the necessary details will be covered by assumptions.
Our primary objective for this project is to work with Professor Gensi to propose a simple, robust and economically viable energy solution for remote communities which incorporates renewable geothermal resources. Additionally, we have specified certain goals to coincide with HAL's expectation and desired outcomes. In order of importance, these are: cost of construction and implementation must be under $5,000, maintenance procedures must be simple with only readily available parts required, electricity generation should sufficiently meet basic needs of the community.
We began this project by developing an engagement proposal letter for our client, where we clearly defined our problem, objectives and scope as we saw them. In this letter, we divided our project approach into 4 main phases, outlining the procedures, deliverables and deadlines of the various aspects of the project. The phases take up roughly half a semester each and can be described as follows. Phase 1 is an introduction to geothermal power and will include a comprehensive literature review, both summarizing general principles and identifying applicable examples currently in operation, as well as accompanying assumptions to be carried into the design process. Phase 2 will involve further development and evaluation of competing design concepts, including a preliminary feasibility assessment for each concept. Then the design concept will be finalized and presented to the client for feedback. By Phase 3 we will have the design concept finalized and we will begin detailed engineering analysis on all aspects of this design. Phase 4 will be the finalization of the design details, including specifications, operating procedures, expected performance, estimated capital investments, and ongoing maintenance costs.
My role for the first phase of the project is to develop and refine our design methodology, specifically how we are going to complete the project and what measures we have in place to ensure we remain on time and on budget. This process crucially extends to client collaboration, ensuring that the team is both fully aware of the client's expectations and addressing the right problem. We have achieved this through an engagement proposal letter presented to and accepted by our client. Accordingly, these tasks are tremendously important to the overall success of the project as they relate directly to client satisfaction.
My role for the first phase of the project is mainly to develop the prior art of the project with a specific focus on the existing solutions as proposed by our project supervisor Hal. This includes extensive research and understanding of the organic ranking cycle and its uses. I have also taken a look at scroll technology proposed by our supervisor to develop a solid understanding of its operating principles. On the managerial side of the project, I have been heavily involved in developing work breakdown structures, Gantt charts, and breaking up technically orientated tasks and assigning them throughout the team.
Within the first phase, my role will be to construct the engagement proposal with the assistance of Morgan to give our supervisor for complete clarification of the outcomes of the project. This includes a concise problem definition, objective, scope, constraints, and details and deliverables of each phase we intend to complete throughout the project. Some preliminary research has been conducted into various heat exchanger technologies that can be used in the system, including types, fins, advantages, and thermodynamic capabilities.
My role for the first phase of the project is to assist Vlad in developing the prior art, with a specific focus on possible working fluids that can be used for low temperature organic break-in cycles, like shown beside me. This includes extensive research into understanding how to choose the correct working fluids for our situation and what good properties are for them. I have also taken a closer look at alternative technologies, which include thermoelectric generators and dry stick power plants, allowing us to critically analyse whether our situation is the best one.
For Phase 2, my primary task will be determining a list of appropriate standardised criteria which will be used in assessing the feasibility of each of the competing design concepts developed by other team members. Based on the project objectives, these criteria will be quantitative and result in the elimination of irrelevant or unsuitable options.
For Phase 2, I will continue my development of the existing solutions with a greater focus on technical specifications and output parameters. I will be working closely with Mitch to develop and understand the alternative solutions and decide on the best approach to solving our problem. By the end of this phase, we aim to nail down the design concept, be it the existing solution or some alternative that we may yet identify, and begin technical designs.
With this phase, I'll participate in the analysis of specific cycle considerations to be included in the final design concept. Firstly, I will detail several options for the design that can then be assessed by the developed criteria. Also, I'll perform basic calculations and deductions to assess the feasibility of our proposed design, with special focus on the heat exchanger.
For Phase 2, I will continue to develop my understanding of working fluids with a greater focus on how it will affect the technical specifications and output parameters. I will also be working with Vlad to critically analyse alternative solutions to ensure we are on our best approach to solving our problem. By the end of this phase, I aim to have chosen a specific working fluid to use and to nail down a singular design concept.
My role in Phase 3 will involve engineering analysis, with particular emphasis on heat transfer problems. Importantly, this will draw on knowledge gained from an extensive heat transfer course I studied in place of MECH4552 while on exchange. I will also explore methods of constructing the power plant in terms of layout, geometry, and portability. Together with other team members' work, these results will be vital in evaluating the overall performance and determining design specifications.
By Phase 3, the design concepts will be finalised and I will be focusing on the thermodynamics of the problem, specifically at the turbine expander. I will also be investigating the electrical side of the problem, investigating how exactly we will achieve electrical power from mechanical work and begin to record down our achievable outputs and initial cost estimates.
Using my experience in CAD, I will also be closely working with Morgan on the 3D and 2D modelling of the skid design and layout.
During this extensive phase, I will perform the final thermodynamic analysis of the heat exchanger in the system, as well as any other necessary components. This includes a direct solution to all variables such as pressures, temperatures, flow rates, and heat transfer. I intend to develop the geometry and design of the skids with the assistance of my colleagues, as well as the costs associated with manufacturing and maintenance. This will all be documented within the progress report and used for the presentation.
For Phase 3, I will be involved in the engineering analysis, with particular focus on ensuring the thermodynamics and heat transfer sides of the project gel together, and helping both Vlad and Morgan with their calculations. I will also use my knowledge of working fluids to ensure the correct components are chosen, and begin to record down our achievable outputs, initial estimation for part cost and maintenance cost.
In the final phase of the project, I will help optimise the design, with my primary focus being CAD modelling and analysis. In addition, I will be responsible for checking and issuing the full set of manufacturing drawings. I intend to model the team's drafting procedures on those I learnt during my professional work placement. Like a recipe to any good dish, these drawings are an essential inclusion in the final project deliverables and complement the design report.
In this phase, I will be working closely with other team members on the optimization of our power plant from a thermodynamics perspective, nailing down the best compromises between optimal performance and achievable values of pressures, temperatures, rotation, power, etc. Depending on the workload, I will also be closely involved in 3D modeling and 2D drafting with Morgan to develop a complete set of technical drawings. Towards the end of the phase, the final project report will also be a factor, and I plan to be involved in the writing of appropriate sections relevant to my tasks.
In the final phase, I'll be collating and documenting my work to the final comprehensive report. Additionally, any extension topics that arise during the course of the project will be investigated by me and included depending on their respective relevance or significance. Depending on the quantity of technical drawings that need to be produced, assistance may be given.
For the final phase of the project, I will be working with the whole team on optimizing the thermodynamics of the design, as well as providing assistance where required, whether it be helping Vlad with his 3D modeling or Morgan with his 2D drafting.
In this video, our group has outlined the process of our approach to completing this project, as well as their motivations for choosing this topic and their individual contributions to the team. We are now at the end of the first phase and beginning phase 2, where we will be looking at completing our preliminary feasibility assessment and converging on a final design concept to begin detailed analysis.